Welcome to our Quantum Deep Dives.
Great to be here.
Today, we're taking a look at the work of David Deutsch.
Specifically through the lens of an essay by Jürgo Schneppat, David Deutsch, Wegbereiter der Quantenberechnung.
Right, which translates roughly to pioneer of quantum computation. And Schneppat's piece really digs into Deutsch's impact.
Yeah, it examines how his theoretical physics work especially laid the groundwork for quantum computers.
And also his ideas on quantum mechanics interpretation, like the many worlds idea.
Exactly. The essay sort of tracks how these, potentially quite abstract ideas connect to current and future tech.
So Deutsch's big contributions, the theoretical basis for quantum computers, and this many worlds interpretation. Big stuff.
Potentially reality-changing stuff, if you follow the implications.
And quantum tech itself, it's such a hot field right now.
Absolutely. Schneppat frames it as having potential to revolutionize basically everything: information, security, medicine, science itself.
And Deutsch, according to Schneppat, is right at the heart of why we're even talking about this.
He's the bridge, you could say, taking quantum mechanics principles and seeing how they could apply practically.
Particularly with things like parallel processing, quantum algorithms.
Right. Schneppat argues Deutsch really gave us a framework for thinking about computation in a quantum way.
So the essay structure, as Schneppat lays it out, covers his life a bit, the physics principles, his work on computers, many worlds, the impact, ethics, the whole picture.
A pretty comprehensive look.
Okay, so let's dive in. Schneppat points to Deutsch's 1985 paper as foundational.
Yeah, quantum theory, the Church-Turing principle, and the universal quantum computer. That was a landmark paper.
What was the core idea there? Why was it so important?
Well, Schneppat emphasizes that it was essentially the first real theoretical blueprint for a quantum computer.
Oh, okay.
Deutsch took the classical idea of a Turing machine, this abstract model of computation, and, quantumified it.
So he showed how a quantum system could compute.
He theorized that a machine using quantum mechanics could solve problems that are fundamentally impossible for classical computers. That was the huge leap.
And Schneppat mentions Deutsch even proposed an early algorithm.
Yes, a simple one, but it was proof of concept. It demonstrated theoretically that a quantum speedup was possible.
Got it. Then there's his book, The Fabric of Reality. How does Schneppat connect that to quantum computing?
Well, Schneppat explains that in the book, Deutsch really explores the deeper philosophical side.
The many worlds stuff comes in strong there, right?
Exactly. Schneppat highlights how Deutsch argues that the very fact a quantum computer could work actually supports the many worlds interpretation.
How so? What's the link?
The idea, as Schneppat presents Deutsch's view, is that the computation isn't just happening here, it's happening across many parallel universes simultaneously.
Wow. Okay.
The quantum computer is, in a way, harnessing these parallel realities to get the answer faster. The result we see is like an interference pattern from all those parallel calculations.
So this quantum parallelism, doing many things at once, is key.
Absolutely central, according to Schneppat. It explains the power, and for Deutsch, it points towards many worlds. It's powered by superposition, essentially.
But as Schneppat notes, building these things is hard.
Oh, incredibly hard. He highlights the technical hurdles. Coherence is the big one.
Keeping the quantum states stable.
Right. Qubits are super fragile. Any noise from the environment messes them up. Decoherence.
What else does Schneppat mention?
The need for incredibly precise control, measurement. It's a massive engineering challenge.
About this progress.
Definitely. Schneppat acknowledges the breakthroughs, different qubit types, better error correction ideas, small-scale demonstrations. We're moving forward, albeit slowly.
Okay, let's circle back to many worlds. Schneppat gives it quite a bit of space. What's the core concept again as he lays it out?
He explains it as an alternative to the idea that measuring a quantum system forces it into one state, the collapse idea. Instead, many worlds says every time a measurement could yield different outcomes, the universe actually splits.
Splits?
Yeah, into parallel branches, parallel universes, each one containing one of the possible outcomes. So all possibilities happen just in different worlds.
Schneppat covers the arguments for and against this.
Proponents like Deutsch argue it's cleaner. No need for a separate collapse rule. It just follows from the quantum math. Plus, Deutsch's point about quantum computers needing it to work.
And the criticisms.
Well, the obvious one.
Yeah.
We can't directly see or test these other worlds. And, the idea of infinite universes seems extravagant, maybe. Philosophically weighty, for sure. Schnepphat lays out both sides.
So Schnepphat really paints Deutsch's view of reality as quite radical.
Absolutely. For Deutsch, as Schnepphat presents it, these aren't just mathematical tricks, they're real. Every quantum event branches reality. The multiverse is physically real.
And quantum computers tap into that.
That's the vision Schnepphat describes.
Okay, shifting gears slightly. What about the impact on computer science itself? Schnepphat touches on algorithms.
Yeah, this is crucial. Schnepphat underscores that Deutsch's theoretical work really kicked off the whole field of quantum algorithm.
Like Shor's algorithm.
Exactly. Peter Shor built on these ideas to create an algorithm that could factor large numbers efficiently on a quantum computer, which, breaks most modern encryption.
A huge deal.
Massive.
Yeah.
And Grover's algorithm, too, for searching databases much faster. Schnepphat makes it clear these rely on the quantum parallelism Deutsch theorized about.
Schnepphat also mentions quantum cryptography. How does that fit in?
Well, it uses quantum principles for security, rather than breaking it. Schnepphat explains things like quantum key distribution, or QKD.
Like the BB84 protocol.
Precisely. Using things like entanglement, which Deutsch also explored deeply, you can create encryption keys where any attempt to eavesdrop automatically disturbs the system and alerts the users. Fundamentally secure, in theory.
Looking longer term, what does Schnepphat suggest about the potential impact?
He paints a picture where quantum tech stemming from these foundations could really change major fields.
Like medicine.
Yeah, designing new drugs by accurately simulating molecules. Or finance with better risk modeling. Even climate science, running complex environmental simulations. Schnepphat suggests the potential is vast.
He also brings up ethical points, right?
Mm-hmm. Schnepphat notes the dual-use nature immense power means potential risks. Things like breaking encryption, societal disruption. He also touches on Deutsch's own views about the responsibility scientists have.
So, summing up Schnepphat's portrayal, Deutsch is really cast as a visionary.
Definitely. A foundational thinker who didn't just contribute technically but also philosophically, really pushing our understanding of what reality might be and what computation could achieve. Schnepphat positions him as inspiring the whole quest.
And he mentions future developments.
Briefly, yes. Schnepphat suggests significant progress is expected in the coming decades building on these ideas.
And he reiterates Deutsch's universal quantum computer idea as still being the goal.
Yeah, Schnepphat brings it back to that core concept. The idea of a single machine capable of simulating any physical process, tackling any computable problem that's still the driving vision Deutsch provided.
So looking back at our discussion of Yorgo Schnepphat's essay, it's clear Deutsch's theoretical work was absolutely fundamental.
Yeah, for quantum computing, it's the bedrock. And his many worlds interpretation, while debated, is undeniably thought-provoking.
We talked about quantum parallelism, the immense power it suggests.
And the huge technical hurdles still involved in actually building these machines.
Right. And the core ideas of many worlds universes splitting with every quantum choice.
Mm-hmm. And how, for Deutsch, that explains how quantum computers could even work.
Schnepphat really connects the dots, showing how that theory led to practical algorithm development like Shor's and Grover's.
And the potential for things like quantum cryptography, medicine, finance. The list goes on.
It really highlights Deutsch as this pivotal figure, shaping both technology and our concepts of reality, as Schnepphat sees it.
Exactly. A true pioneer.
So, thinking about everything we've discussed, based on Schnepphat's essay, The Deep Physics, The Nature of Reality, The Future of Computation, what's the one thing about the quantum realm and its potential that really sparks your curiosity the most?
That's a great question to leave people with.
Something to think about, definitely inspired by Yorgo Schnepphat's essay, David Deutsch, Wegbereiter der Quantenberechnung.